Well, welcome to today's Oracle Machine Learning Office Hours use case session. Our topic today is customer segmentation approaches using Oracle Machine Learning and Oracle Analytics Cloud with Miles Novotny. I'm your host, Mark Hornick, joined by Sherry LaMonica. In this session, Miles will introduce us to customer segmentation and how to build machine learning models using Oracle Machine Learning, using both supervised and unsupervised techniques. It'll also highlight the visualization capabilities of Oracle Analytics Cloud using those models. So before we begin, let's have a quick poll. What is your familiarity with the customer segmentation use case? Would you say that you've developed and deployed customer segmentation models, or you've built customer segmentation models for experimentation? You've heard and read about customer segmentation, or you're totally new to the customer segmentation use case? So let's start our poll there. Okay, so we have a reasonable distribution. We have about a quarter of our attendees that have developed and deployed customer segmentation models. About a third are new to customer segmentation use case. And about another third on that have heard or read about the customer segmentation use case. All right, well, thank you very much for participating in our poll. And we will now head over to Miles. So Miles, take it away.
All right, thank you for the introduction, Mark. So my name is Miles Novotny. I'm a cloud engineer here, specialized in analytics and machine learning technologies. And yeah, I'm excited to talk about this customer segmentation approach using OML and showing off the tight connections it has to Oracle Analytics Cloud. So looking at our agenda for today quickly, I'm going to talk about customer segmentation in general for a bit. And then we're going to talk about using Oracle Machine Learning for segmentation, visualizing those results in OAC, and also go over a demo with both of those things and finish with some Q&A. So let's go ahead and hop into this, looking at customer segmentation. So it's important to define what exactly customer segmentation is. It looked like a number of you are already familiar with it, or have even done customer segmentation modeling yourself. But customer segmentation is just the grouping of customers based on any shared characteristics with the goal of, personalizing your marketing, improving your services, or your sales efforts. And there's a lot of different types of segmentation, and some that people might not really think about. I think the first two on this list, demographic and geographic segmentation, are what I think of when I think of customer segmentation. Where do people live? What are their attributes like age, gender, education, and how do we reach those different people? But there's a number of different other techniques, like psychographic segmentation, all about people's personalities, attitudes, values, and how do you speak to those. Technographic segmentation is super relevant. In today's age, if you have an application, are your users using it on mobile devices, on desktops? What do those experiences look like? You can have behavioral segmentation, again, about how people interact with what you're selling or what you're offering. And then needs-based segmentation is all about improving the customer experience, right? What are the must-haves that people have, and how do we meet the must-haves of all of our different types of customers? And then values-based segmentation is really interesting, all about the economic value of your different customers, and basically, targeting those customers that have high value to your business to really increase that revenue. So there's a lot of different ways to approach segmentation, but why does segmentation matter at all? Why is this a good use case? First of all, it's great because it's applicable to a huge amount of industries. Anywhere where you have customers or users of any kind, whether that customer be another business or a consumer, you can benefit from customer segmentation. If you look online, there's endless statistics about why segmentation is helpful, the impacts it can have. I just have a few of them here, such as a MailChimp survey that found that if companies segment their email campaigns to reach different users in different ways, you can see a 101 increase in the clicks they get. Canon, the camera company, had a really interesting situation where they're able to increase their market share by 40% in the low-end camera market because they segmented their customers and found that adults don't buy low-end cameras because their smartphones have cameras, so there's no reason to buy a cheap camera. But children who don't have smartphones would want to buy these cameras. So something that might seem very obvious, but when you segment your customers, you can see these things and improve the way you're selling to your customers. And there's a lot of use cases for segmentation. I kind of touched on them a little bit, talking about the different types, but anything from retention to finding new customers, identifying those high revenue customers, or improving your product to meet the needs of your customers are all really important things to your business that can be solved by segmentation. And segmentation is something that is greatly improved with machine learning. It's been around for a long time. Businesses have always wanted to understand who their customers are and how they can better meet their needs, better sell to them. But machine learning really takes segmentation to another level. You can do it with much more speed using machine learning. You don't have to, power through the numbers of all of your customers to try to understand what they're like. You can quickly train models and retrain them, rapidly scale them out as your business scales, and also avoid the biases you might see with humans doing the segmentation. A human might have some idea of what the customers already look like and let that bias come into the way they understand hitting groups. But machine learning, that's obviously less of an issue. So customer segmentation is something that is very valuable to a wide variety of businesses. So what does it look like in the context of machine learning? So I'm sure most of you are aware that you have two types of machine learning models, being unsupervised and supervised. And these two types of models lend themselves to some different approaches when it comes to segmentation. So obviously with unsupervised models, there's not a variable of interest that you're targeting. You're just throwing a set of data at this model, and you generally use a clustering model, and it's going to identify those clusters, after which a human could go in and assign names to them, right? So this is like a demographic example with age and income. And your model would identify these clusters, and then it's up to a person to give them those labels. The supervised approach, this time we do have that target variable of interest. It could be something like the buying habits of a customer, whether or not they bought a product. And you would generally want a supervised model that will generate a set of rules, like a decision tree model, because you could then analyze those rules to understand, what decisions go into making somebody likely to buy something or unlikely to buy something. And you can kind of get a hierarchy like we have here with these set of rules. Like if somebody's high income and they're young, they might want to buy a sports car. But if they're more middle income and married and older, they might want a family car. So instead of like assigning names to these segments in this case, you can assign names and group together sets of rules that define whether or not somebody would take an action, buy something, for example. So you get some different approaches here, and we're going to be showing off unsupervised and a supervised example today to see a little bit about what those two can look like. So let's talk specifically about the Oracle machine learning context now. So as I mentioned, we're going to have an example of both of these types. And the company we're going to be using today for this example is called Oracle Movie Stream. This is a set of synthetic data for a streaming service. Just think of Netflix, for example. So we have a set of customers, and they get free content they can watch, and then they can also spend additional money to watch select movies and shows and such. So we have a couple goals with this company that we're going to try to meet with these two approaches. First of all, our unsupervised approach, we have a set of demographic data. We want to identify our different types of viewers. And in doing so, we want to improve the experience for those customers and also retain those customers. So we want to identify different groups like dinks, single young people, large families, and then how do we curate this platform to make all these people happy? And in this case, this will be a clustering algorithm, and we are going to be using k-means. When it comes to the supervised approach, we are going to be analyzing the spending habits of our customers. We have some sales data that we're looking to aggregate together, look at how much our different customers spend on an annual basis, and use that to put them into some different bins from our very high spenders to our low spenders. And then we're going to train a decision tree model with this as our target and try to analyze the rules that make somebody likely to belong to one of these groups or not. So that is the approach we have today with our two segmentation models. So that's the Oracle machine learning half of this, but we also have Oracle Analytics Cloud involved. So Oracle Analytics Cloud, or I might say OAC for short, is Oracle's enterprise scale business intelligence platform. You can create your really stylized dashboards and reports. You can even embed these visualizations you create into other applications or websites. There's some really tight integrations with Oracle Machine Learning. We'll see that you can even register Oracle Machine Learning models to score data from the Oracle Analytics Cloud interface, which is really powerful and really enables your analysts to do some really cool things with the reporting that they create. So we're going to show off just how tightly these two technologies are integrated and how well they work together. So with that, I'm going to jump over to our demo. Okay, so our demo is going to begin here in our Oracle Machine Learning's notebook interface, and then we'll move over to Analytics Cloud for the second half to really visualize the results of our clustering models and look to understand those clusters. So we're going to start off with our unsupervised approach. So in this case, we're looking at customer demographic data. First thing to do is try to understand this data. We have a bevy of information about these customers, a lot of location data about where they live, how long they've been a customer, which is very important, how old they are, information like their household size and gender, a lot of useful stuff we can use to try to segment them. And Oracle Machine Learning does have its own quite powerful visualization tools. So we can gain an intermediate understanding of these customers before we cluster them, such as where they're located. We can use this map to see there's a lot in Europe and the Eastern US, as well as Africa, South America. We can look at the gender distribution. We have slightly more women on our platform, as well as the continents that our customers are from. Their education distribution, age and income distribution, lots of ways that we can look to understand these customers to take the best segmentation approach. So now that we understand that data a little bit, we can train our k-means model with this OML for SQL example right here. You can see we're choosing that k-means algorithm type. It's a clustering model. And then right here, we choose a subset of that customer data that we want to actually use for the segmentation. So customer ID is our unique identifier. And then we're using gender, household size, income level, marital status, country, and age to segment these customers. So we train that model, and that runs successfully, after which we can view the associated data sets to this model, which have important information defining what these clusters look like, the model settings used to train the model, lots of important information in these data sets. Some of these are data sets that we'd like to visualize in Oracle Analytics Cloud when we get over there. So it's nice to look at these and think about which ones we're going to visualize. And we can also look at some of this here, looking at cluster details, for example, seeing these cluster IDs, the tree level, its parent. So we've created that model, and at this point, we're going to leave that there and continue with the unsupervised model in OAC. So we can now move on to creating our supervised approach. So again, this is a decision tree model looking to identify those big buyers and what defines them. So this time we have our sales data, and this is pretty standard. We have the ID of the movie that the person bought, the customer that bought it, the app they bought it on, and then the price information. So we want to aggregate this all together. So we have a number of different SQL statements here. This one creates an aggregated view, taking the sum of these prices and looking at them by cust ID, again, to aggregate those purchases by customer. We combine this aggregated data with our demographic data, and then we add some columns for those annual values, right? We wanted to look at the sales information on an annual basis, so there's not a large bias towards those customers that have been on the platform for a very long time. So we create a column for annual purchases and number of annual movies watched, at which point we can create these bins, right? And we look at the data and kind of understand cutoffs that would make sense as to these different bins from low spender to high spender. So at that point, we have our data set ready for this decision tree model. It has our same demographic data but if we go to the very end, it also has this aggregated sales data. Great. So we can, again, look to visualize this data. Now that we have the sales data included, look at our sales by country, by gender. And then we go to create a train and a test split of this data. We again choose a subset of those columns, which we would like to use for this model. Our data at this point has a large amount of columns, so we want to be careful about only including those that we think would be impactful. And then we go ahead and train our model using that training data set that we just created. And that happens successfully. And again, we can look at some of these model views to understand which data sets we might want to visualize in Oracle Analytics Cloud. So at this point, we have trained both of our models, gained an intermediate understanding of our data, and now to create some rich visuals to really understand what's going on, we can move to Oracle Analytics Cloud. So we're going to go ahead and do that. So here we are on the OAC homepage. There's a lot of things that you can do in OAC, but I really want to draw attention to these connections between Oracle Machine Learning. So the first thing you would do to integrate Oracle Machine Learning with OAC is to create a database connection to an autonomous data warehouse, likely. So you put in your wallet file and then a username and password. And the username and password of this user defines which data, which models you're going to be able to access. Whatever this user can access in the database, you'll be able to pull to OAC to use. So you would go ahead and create a connection, after which you can interact with the data that's sitting in this database as well as the models. So I already have a connection created, and say I want to import over those models I just created. I can just come in here, register model or function, choose machine learning model. I pick out the name of the database connection that I created. And now I can see all of the models that this user has access to in that database. For example, this decision tree model that we just went over creating. So I can choose to register this, give it a slightly different name if I'd like. I can see all of the information about which type of model it is, look at the input and the output columns, make sure I understand what I'm working with here, especially if this is a model that somebody else created and gave me access to. I can fully understand what's going on. And then simply click register. And I can go ahead and use that model here in Oracle Analytics Cloud, which is very cool. And then when it comes to the application of that model, you go to this data flow interface of Oracle Analytics Cloud. You can do a lot of things here, a lot of data preparation techniques, blending of data. We'll just focus on the model aspects of this. So you can see I choose the data set here. This is our test data set from that decision tree model we made. And here we can apply that model that we registered. We'll come here and choose apply model. We see this decision tree model that we registered from our Oracle Machine Learning, and we can choose that. It tells us the outputs that we're going to get. So the prediction, the predicted bin, if they're if they're a high buyer or a low buyer, the probability for the prediction. We also have the option to compute lift and gain charts, which can be very useful for understanding your models. And then we'd simply save this data as a last step. And these results can actually be saved right back to your database connection. So by default, this output table that's created would be saved back to the database, which is really useful, again, for sharing so that others can just access it right from the database again. Now, an important thing to mention about this is that I say I'm using this model from Oracle Analytics Cloud, but everything is still happening within the database. When I create the data set, it's able to query the database and show me that data, but that data still resides there, and the model still resides in the database as well. Essentially, by doing all this in Oracle Analytics, you're able to remotely access the database and make all these things happen there. So this is still all in database scoring, in database training. Your data is not moving when this happens, which is very nice. So that's how you'd go about applying this model. We save our data at the end. We would just hit run on this data flow, and we would be given that output data set that we could work with either in Oracle Analytics Cloud or back in our database, because it's also still resides there. So that's how you would use a registered model from OAC here. Let's look at what some canvases could look like to visualize these results now that we understand how we'd apply this model as an analyst in Oracle Analytics Cloud. All right, so we have our two canvases to show off, one for each of our approaches, supervised and unsupervised. And first, we're looking at that supervised decision tree approach. So on the left, first, we can see the structure of this decision tree that we made with all our relevant leaf nodes at the bottom here. And on the right, we see an interesting visual showing us the distribution of these bin predictions across our customers. So we can see our largest customer segment is those low spenders. That's not too surprising. About a quarter of our customers are average and high spenders. And then that very small 4.6% as the very high spenders, that segment that we would like to increase along with the high spenders. So moving down, we have the most important part of this canvas, which is the rule set for this decision tree that we can, again, assign a name to a set of rules that we find compelling for defining these different sets of customers. So we get a rule by taking predicates that are associated with each node. We start with our leaf node at the bottom and take the predicates of the nodes, of its parent nodes, all the way to the top of the tree to get a given rule set. So we can see some examples here and see the type of customer they're predicting for, such as node 41 is predicting for an average spender. And when we combine the predicates up the tree, we get this set of rules. You know, they've been a customer for less than 6 years, but more than 4 years. They do not work full time, and this age is between 6 and 11. So this is targeting the very young viewers of this platform. So we can analyze these rule sets, find the ones we find compelling, and then again, assign a label to them and use them for our business logic when it comes to marketing to these high spenders, for example. And if we want to target one of these segments, we can use this filter up here, maybe just see the rules associated with our high spenders, because maybe that's really the area that we want to maximize and to market to. So the most important thing here, again, identifying these compelling rule sets. Another thing we can do with this model is kind of look at the average values associated with these different customer segments. So if we just look at our customers as a whole, our average customer age is 45, 2.5 people in the household. They've been a customer for like 4 years. But we can look at how this changes when we analyze some of the different segments. Like if we want to look at our high customers, our high spending customers, we can see how these averages change. It looks like our high spenders are an average younger, a little bit larger household, and much newer customers. That's interesting. The income actually dropped a little bit. So it seems that how much they spend on the platform isn't totally correlated with income, but just how much they enjoy our products. We can also look at the very high spenders, one more example, and see how these values change. We see that average age dropping lower, the average year's customer also dropping lower. So it seems that our high and our very high spenders seem to be a little younger on average, smaller households, and newer customers. So we can also gain some insights there by looking at these average values. So that's a look at our decision tree model and analyzing that. And now we can move on to our unsupervised k-means approach. So again, we can see the structure of our tree here and some interesting information about these different clusters that we have identified. So we can see the different sizes of these clusters just based on the number of customers in them. So some are larger than others, like cluster 16, and we can compare the size then to the annual revenue we receive from these different clusters. And this becomes very interesting because there's some smaller clusters like cluster 3 who account for a large amount of that revenue, a very outsized amount. And then some of our larger clusters may account for a smaller amount of the revenue. So this could be an interesting way to analyze these clusters. Not only are you identifying these segments, but you can also understand which segments are contributing a lot to your revenue and which ones are not. So down here is where we can analyze our different segments. So say I find an interesting one like 16 right here. Again, this is a larger cluster identified, but not contributing much to revenue. Let's see what this looks like. So we can use this filter, and then this tells us all the attributes associated with the people in this cluster. So this cluster is only female buyers, and they are either married or single. It looks like they can be from pretty much any country that we sell to and at any income level. We can see the age range of this cluster. So this is older women from 51 to 80, okay? And their household size ranges from 1 to 3. So we're looking at older women with a smaller household, maybe a partner and one other person. We can also look at the income distribution for this cluster, fairly even, leaning towards the lower end, as well as the distribution of countries for this cluster. So that's very interesting. And the great thing about this interface is that we can compare clusters to each other. So 16 is interesting. What if I wanted to look at 3? This was one that had a very outsized impact on revenue. So we add 3 here, and we can look at this comparison. So cluster 3 is this pinkish color, and this cluster is both men and women who are single, again, from just about any country, but only at the lower income levels. This is interesting. So the age range is much younger. We're looking at 16 to 23. Very interesting. And very large household sizes, 5 to 10. Okay, so these are some very different clusters. It looks like young people in general are having an outsized impact, spending a lot of money on our platform. This could be a potential students segment. You know, they're young, large households. So, you know, this is how you kind of go about assigning these labels to these different segments. I can kind of look through this and understand this. These might be students, and then we have older women in this other segment. You can also combine multiple clusters together into one segment if they're very similar. These two aren't very similar, but we could try to look for some other ones that work together. If we want to look at cluster 14, for example, and see how this compares to 16, we can see that this is men this time, married or single, but the age ranges here are the same, and those household sizes are similar. Okay, so we could create different segments for older men, older women, or we could bring them together and just try to market to them as one segment. It's really up to you at this point. You have a number of different clusters that are created. Some of them might be similar. Some of them will be very different, like we saw with 4 and 16. So you can combine some of these clusters together into one segment, or have a cluster standalone as its own segment. But this type of comparison is very useful for understanding your different clusters and then assigning these human readable names to them. So we can just do one more example. Let's look at cluster 11 and see what's going on here. All right, so in this case, we have married men and women, any country, any income level, it looks like. And our age range is 37 to 58 this time, so a little younger than the other clusters we were looking at, and large households. So this could be more of like a families with kids type situation, being that it's big household and middle-aged people owning these accounts. So married with children could be this cluster, right? So this is just kind of, again, the approach you'd take to naming these different clusters, after which, you know, you could try to retain these customers, try to make sure that these different segments have what they need on our platform. So with that, I'm going to end our demo portion here, and we can hop back to the slides to finish up. All right. So I think it is time for our second poll.
Yes, well, thanks, Miles. That was a great demo and introduction to customer segmentation. So, for poll number 2, how has this session helped your understanding of customer segmentation? Would you say you were new to customer segmentation, but now have a good understanding of how to use OML and OAC in this context? Or you're more confident, but still have questions about how best to address customer segmentation? You feel confident to start using these tools, or you've already used OML and or OAC for customer segmentation, but this reinforced or enhanced your understanding. So let's start the poll. Oh, excellent. So we have over half that they were new to customer segmentation, but now have a good understanding of that. And about a quarter are more confident. And we even have some in the other categories as well, where that 10% have already used OML and OAC for customer segmentation, and about 15% feel confident to start using it. Well, that's fantastic. So thank you for the feedback on this poll. And Miles, if you want to continue.
Sure thing. So just wrapping up here, we have some information on this topic for you in these slides. Information about customer segmentation, about Oracle Analytics Server, as well as the algorithms that were used to train these two different segmentation models, being, again, k-means and decision tree. And then additionally, we have information about Oracle Machine Learning, our blogs, GitHub repository, office hours, a number of live labs that you can try if you'd like to get hands-on with this technology yourself. So with that, I'd like to thank everybody for their time, for coming today, and ask if there's any final questions.
Well, we did have 2 questions that showed up in the Q&A. We've answered them, but we'll just perhaps recount them here. Can these rules be forced by business logic? And the basic idea is that if you've got the machine learning model, the rules are fixed in that. So you're not able to go in and change the rules themselves. But we do find, there are some customers that will use a model as the basis so they understand what the rules are, but then they might want to tweak them slightly to have certain boundary conditions. And so they'll craft the rules explicitly for that based on the input from the model. In other cases, you could have post-processing. So you get the prediction, but then you might apply some additional business logic around that to define more carefully what is done. And so that's really, in the case of the rules for the supervised cases Miles showed, business judgment, could be added by saying, well, how did we define that target value? The level of spender was there. That was a business decision to say, how did we want to capture the level of spending? But then you wanted to know what were the customer segments that originated from that. So thank you for those questions. All right, with that then, Miles, thank you again for a great presentation and demonstration, and we will see you next time.